going to take this introduction, or this opportunity to introduce her. I don't know that she would brag on herself sufficiently. Morgan did her undergraduate work in the Earth System Science and Engineering Department at the University of Michigan, and she's now working in the Earth System Science Department for her PhD at the University of California, Irvine, in Dr. Zinder's lab. I think it's fair I can say this since it's on the paper. In her graduate work, she has a 3.97 GPA on a 4-point scale, which I'm just dying to ask her what the B is in. And she also just recently received from the Department of Defense a National Defense Science and Engineering Graduate Fellowship. And this is one of those fellowships where they say, we're not going to tell you what to study. We're so impressed with your scholarship. We simply want to give you this money so that you can study. I think that's pretty remarkable. So, Morgan Gorris.
Thank you very much, David. I'd like to clarify it was an A-, and I'm still a little bit bitter about it, but I'm working through. But thank you all for being here today, and I'm very excited to share with you our results from year 1 of our study characterizing and evaluating historical air quality here in Borrego Springs. So to start off, a very compelling picture here of a beautiful sunset in one of the new particulate matter air quality stations that was recently set up here in Borrego Springs. So just a little outline of what I'm going to be going through today. I'll give you some motivation and background information for this study. I'll look at our objectives and the data we used, and then look at historical air quality trends in the preliminary results from our new weather stations that were assembled here, and then finish up with some conclusions and actually an opportunity for you all to be involved with this study. So those past 2 pictures were very beautiful, clean air pictures, but I think some of you know that it doesn't always look that way here in Borrego Springs, especially when a dust storm comes through. This is a YouTube snapshot that Seco Rude took of a dust storm that came through in April 2013. And you can only imagine the health effects and just the nuisance of having so much air quality issues and dust issues when you're trying to drive or go outdoors. So this is one of the motivating factors, as David put it earlier, of why we're studying air quality in this region. And we know it doesn't always look this bad. It usually looks more like this, where you have visibility issues out in the distance, possibly coming south from here near Ocotillo Wells. So again, this is really what's driving this study. So we know that dust is a pollutant. It causes both environmental issues as well as health issues. It reduces visibility. It can cause upper respiratory infection. It can cause issues for asthmatics, especially in young children and in older populations. And the smallest particles in dust are so small that they can actually get into your bloodstream. So it's something that the Environmental Protection Agency monitors as a pollutant. We know that local activities, such as the tilling or following of lands, off-road vehicles, construction, can increase dust emissions. And for those reasons, there's been concerns about the dust air quality in Borrego Springs. So like Charlie put it earlier, the Borrego Valley Endowment Fund has funded a 3-year study where this first year we assess the current state, historical variability and trends in particulate matter air quality. And in the next few years, we'll be developing a regional dust model to start simulating dust events. And then in the 3rd year, we'll begin to attribute sources to these dust events and obtain actionable information so we can plan for air quality changes in the future. So So particulate matter, I'm sorry to throw some jargon at you, but particulate matter is the encompassing term that describes particle pollution in the atmosphere. So this is small or liquid, solid or liquid small particles, and dust is included within this category, as well as other particles such as soot, sea salt, sulfates, and nitrates. And particulate matter as a whole is considered a pollutant by the EPA, and so there are certain standards that a region must meet in order to be considered a healthy environment. There are two particular sizes that the EPA monitors: large particles, which are referred to as PM10, or particles that are smaller than 10 microns, and then small particles, or PM2.5, particles that are smaller than 2.5 microns. And just to give you a sense of how small this really is, this right here is a depiction of a human hair. And in blue here, we have the size of PM10. And in red here, which fits within this blue particle, we have PM2.5. And to size this up, this is fine beach sand, which is 90 microns in diameter. So we're talking about very small particles, even when I say large particles. So the goal of this first year was to assess the current state, historical variability, and trends in particulate matter air quality, which includes dust within that category. The data that I'm going to be sharing with you guys today comes from two different sources. For the historical variability and trends, I'm going to be sharing with you some data from MERA-2, which is a NASA product. It uses satellite and weather station data to kind of reanalyze the surface conditions here on Earth. And it's at a resolution that's satisfactory for studying the regional changes in air quality. And then for the current state, I'm going to be sharing with you some of the data from the new weather stations that were assembled here. They all came online last year in October 2016 is the last one. So we have 7 new weather stations, 5 of which have particulate matter monitors on them. And here is a picture of one of them. So this is a diagram of what the MERA-2 data looks like. This is average surface dust concentration from 1980 to 2016. And what you're looking at here is Southern California. We have the Salton Sea here outlined in black. We have Borrego here in red. And it stretches across 2 of these MERA-2 data cells here. And so if we take the average surface dust concentration over time, it gives us a picture of kind of what we suspected. We have lower dust amounts along the coast. We have higher dust amounts as you travel east into the more dustier desert regions. And so this gives us a good verification that this is a good data source to be looking at. So on average, if you average these 2 cells, we're at about 33 micrograms per meter cubed of surface dust concentration. And just to give a sense of what kind of the dust variability looks like over this time frame, even over a month, I'm going to play a video here of the surface dust throughout January. So you can see it's highly variable. We have days with clean air, we have days where we have large dust events that come through, and really the local and regional weather is driving a lot of these changes, shifting the wind and bringing particles in from different sources. So this is just to give you a sense of kind of what the variability in the data looks like. So if we take this and plot it over time, so we're looking at the surface dust concentration over time, you can see it's highly variable. We have all dust sizes plotted here in blue, and then we have the small dust sizes plotted here in red from 1980 to present into 2017. And you can see it's variable, it's very cyclical with the seasons. We have peaks in the summer season, we have dips in the winter seasons. But it's a little bit hard to just figure out what's going on with all of this noise. So if we break apart both of these graphs into two separate panels, oh, I got ahead of myself here. Okay, so if we put a trend line in through this data, we see that although our eye may not have told us, the math here tells us that both all dust and the small dust is increasing over time. All dust is increasing at 0.22 micrograms per meter cubed per month, and small dust is increasing at a bit slower rate at 0.05 micrograms per meter cubed per month. Okay, so now we can separate those two into two different panels so it's a little bit easier to view. And you can see that they basically match perfectly with the overall trends and cyclic patterns of the surface dust concentration. So on the top panel we have all dust again, and in the bottom we have the small particle sizes. So we know that wind accounts for a lot of the dust events that we have here in Borrego. And in fact, if we plot the wind data against the surface dust concentration, we see it accounts for about 50% of the variance in dust. And just looking at these by eye, you can see the dust follows the wind patterns quite well. And this is something that we've understood for some time. I mean, windier conditions cause erodible soils to be lofted into the air. So if the dust is increasing over time, then maybe it's just the winds that are increasing over time. So here I put the trend lines back in the two for the dust. But if we put the trend lines in for the winds, they're actually not changing over time. So something else must be causing this increase in surface dust. So other things such as the falling or tilling of land, the off-road vehicles, or just the amount of available soil that can be eroded. So if we take the average seasonal cycle, we see that all dust in blue peaks in summer periods, and small dust in red here also peaks in the summer periods. And this is kind of what we expected. There's more dust when it's a drier condition and hotter weather too. It's lowest in the winter. It dips down to about 20 micrograms per meters cubed. And it's highly correlated with wind. Wind explains over 70% of the variance in surface dust. So again, a lot of this dust can be attributed to our local wind patterns, but there's still some variance left over that has to be accounted for other causes such as human disturbance of the land. So an overview of some of the historical trends. Since 1980, both the surface dust concentrations have been increasing, both all dust sizes and the small particles. Winds accounted for up to 50% of the variance in surface dust concentration. However, they're not increasing over time, whereas the surface dust is increasing over time. So other factors are definitely responsible or have to be playing a part for this increase in dust. And so from this historical data, we can now anticipate what our station data is going to look like, especially that seasonal trend where we anticipate our stations to have the highest dust concentrations in summer. So I'd like to shift over to talking about some of the preliminary results from our new weather stations in Borrego Springs. This is a picture of one of the stations. This is another one of the stations. This one is located near Wilcox Well, and it has a lot of interesting gadgets tied on to this station here. We have a lot of the typical weather measurements happening. We're looking at winds. We have a rain gauge, temperature and humidity. It's appropriately situated, grounded in the earth, and has a lightning rod for any of our severe storms that come through to protect our instrumentation. We're also looking at solar radiation, and there's little panels in the dirt that measure soil moisture and soil temperature. And then these stations talk to each other and ultimately send the data back here to the research station by being powered by a solar panel and then talking with the antenna via radio waves. And unfortunately, at the time when I took this picture, the dust monitor was not installed. It's kind of boring looking, to be honest. It's a little gray box, and it counts the amount of dust by using a laser and measuring the amount of light scattered within the box. So these stations were set up all over Borrego Springs. We have the one here right at UCI at this research station. You might have seen it when you came in. It's right out front here. And that one's measuring all size particles. We have one set up at the elementary school that's measuring small particles. And then we have three, one at Viking Ranch, Clark Lake, and Wilcox Well, that are all measuring the large particles. And then we have a few stations over here that don't measure the particulate matter but do have other weather data. So kind of like the historical data, our daily data here throughout Borrego Springs is pretty variable in terms of particulate matter. So this is from April 1st of 2016 to January 15th of 2017. We have the elementary school plotted here in blue on top, which is measuring small particles. We have Viking Ranch in green, Clark Lake in red, and Wilcox Well, that's in purple, you can see it overlaid, that are measuring the large particles. And here at the research station, we are measuring all sizes, plotted here in pink. And you can see a lot of events are individual to each station, where you see a peak at one station or maybe a few stations, but not at all stations. So we're picking up a lot of the interesting micrometeorology that's happening here in the region. But we also have some events that you can see happen at multiple stations, especially this one in late July that really got picked up in all the stations. So these will be interesting case studies to come back and look at when we begin our modeling aspect of the project. Overall, Viking Ranch has definitely shown the largest amounts of dust. Visually, we have confirmation of this. This is a picture shortly after the fencing was installed to protect our station. You can see about 8 inches of erosion that happened in the order of months at Viking Ranch. Zooming up a little bit closer, some of these sensors in the ground actually had to be redug, and the fencing had to be fixed to secure it around the station. So we know we're getting a lot of activity out there. Again, if we take this data and we make a seasonal cycle, we expect it to follow the historical trends, and that's what we see. So on top, again, we have the elementary school measuring these small particles, Viking Ranch, Clark Lake, and Wilcox Well measuring the large particles in the second panel, and the UCI Desert Research Station measuring all size particles on the bottom here. And the shaded area is one standard deviation away, so it's starting to show the variability in the amount of dust that happens throughout this time period. So the elementary school, we can see peaks in the summer and has a high variability in the summer months. The sites that are measuring the large particles also tend to peak. Viking Ranch is showing a peak in the later spring and highly variable amounts, and Wilcox Well as well peaks in the summer. And then the research station is also peaking in June and July. So these are consistent with trends from MERA2 data, so we know that our stations are definitely on the right track, and eventually when we get a full year's worth of data, we'll be able to fill in the rest of these trends and keep an eye on these. So now to get into a little bit of the nitty-gritty. So the Environmental Protection Agency through the Clean Air Act, set up national ambient air quality standards. And these are the amounts that the pollutants cannot exceed in order to be considered healthy environmental conditions. So these standards cover 6 of our major pollutants. One of those is particulate matter, which encompasses dust. And they monitor both sizes, both the small and the large particles. And then they have 2 different types of standards that the National Air Quality Standards monitor. The primary standards protect human health, including the sensitive populations, like the people with asthma. And then the secondary standards provide general welfare protection, like for visibility and damage to buildings and crops. And here are a few of our typical culprits for causing a lot of these pollutants: car exhaustion, pollution from factories, and then for particulate matter, really human activity. So I'd like to share with you how our stations are comparing to these standards as of right now. So for the elementary school, there's 3 different standards that we need to meet for the small particle sizes. Our annual mean, averaged over 3 years, cannot exceed 12 micrograms per meters cubed to not exceed the primary standard, 15 micrograms per meter cubed to not exceed the secondary standards. And then there's a third criteria: our 98th percentile of readings averaged over 3 years cannot exceed 35 micrograms per meter cubed. And so far, our stations are below these levels. We're reading in 5 micrograms per meter cubed, and then our 98th percentile is at 17 micrograms per meters cubed. So far, so good at the elementary school. That's pretty good to hear, considering we have a lot of other air quality issues that will be coming about. So we're at pretty good standards right now. For the large particle sites, we're not to exceed 150 micrograms per meters cubed more than once per year on average over 3 years. And this is where we're closer to exceedance than any of the other stations. So at Viking Ranch, right now, our maximum daily value is 97.4 micrograms per meter cubed, which is getting up there. So we'll definitely be keeping an eye on that. So far so good. We're not exceeding any of the EPA standards, but again, we only have less than a year of data, so this is something that we're going to be continuously tracking. So overall, throughout year 1, we found out that since 1980, surface dust concentrations have been increasing in Borrego Springs. Winds accounted for over 50% of the variability in dust, but that leaves some open room for other sources to be contributing to the dust in the region. Historical and weather station data both showed increases in dust in the summer, and this coincided with the hot, dry weather. And our stations do not currently violate the EPA standards for particulate matter, but again, we don't have a year's worth of data, so that's something we'll be keeping an eye on. So for year 2, we're going to begin to calibrate our station data with the nearby stations that you saw on Charlie's map earlier. And we'll begin to develop the local dust transport model to simulate dust events and help tune the model to make sure it's measuring the correct dust amounts in this region. And then in year 3, we'll start to attribute sources to those dust events and really get some actionable information so that you here in Borrego can use this as a planning tool. So I'd like to invite you all to participate in this study as a citizen science opportunity. If you would like to submit a dust event that you see, I would be happy to hear about it. Submission requirements are really your name and email so that I can get a hold of you if I have any further questions. The start date and the time of the event, and the end date and the end time of the event, if you know it or if it's ongoing, that's okay. The location of the event and any additional description, you're free to send me a picture as well. So these requirements are going to be summarized in a little form, and hopefully in the next coming months here, it'll be available on the Borrego Valley Endowment Fund webpage. And I'll also have a link on my website that basically redirects you to the Borrego Valley Endowment Fund webpage. But I would be happy to look at some of the events that you guys see that we might be missing here with our stations. So I'd like to say thank you to the Borrego Valley Endowment Fund for funding this project for 3 years. And I'm very excited to continue working on the air quality here in Borrego Springs. And also to the National Defense Science and Engineering Graduate Fellowship for funding me as a student. And then also thank you to you guys for coming here today. I'd be happy to take any questions. I have my contact information up here, and we'll leave you of a picture with me struggling to keep my eyes open here in the Borrego sun. So thank you. Yeah, question in the back.
I noticed that they're spraying up at the Viking Ranch area this week, the groves. And I wonder, are you doing any sort of breakdown of how much of the particulates are pesticides, herbicides, and things like that? Or are your particulates basically just all-inclusive? In other words, if there's an area where there's a lot of activity going on, is there a breakdown of what's in the dust from that area?
Right, unfortunately, no, not with our monitors. So our monitors are particulate matter monitors, so they're encompassing anything that's a small particle pollution. Where we can get some of that breakdown is through the MERA data, where there's an algorithm that NASA developed that can start to categorize the different particles and what they are. So kind of some intercalibration between what we're seeing here through our monitors and what the other data tells us will give us a better idea of that. Yeah, thank you. Yes.
Good job, by the way.
Thank you.
So I have several questions.
Yeah.
One of the future signals of climate change is sort of dry and warmer winters here, and overall drying trends here in the south. And so your soil sensing systems, are you using CDR probes, or what sorts of sensor technology are you using? Are you doing it at depth? And I know it's really early to say is there a trend so far, but I'd be curious how it varies geospatially.
Yeah, so that is actually one of Travis Huxman's projects in full. I unfortunately have not looked at any of that data yet. I know they are doing different depths of the soil, and the weather stations up along the grade also have the soil measures on them. So they are getting an elevation gradient with those.
Right. You don't know what particular sensors.
No, I'd have to get back to you on that one.
Okay.
Yep.
No worries. I
Yeah.
can reach out to you.
Okay, okay.
My second question really has to do, again, it's probably way early in your study, but how does geomorphology in the valley affect these particulate levels? I certainly know that Viking Ranch is downhill from Scotty Canyon, and it's very sandy there and very fine in comparison to other parts of the valley, which are more rocky and such. So it seems like localized production of particles will also influence the density of it above when it becomes airsoft.
Definitely, you're absolutely correct. I mean, I think Viking Ranch is kind of the example that really stands out for that. Within the first couple months, we saw that much erosion, whereas we didn't have a problem at any of the other sites. And I think just when we're analyzing the data, looking across the scales to see if it is a micrometeorology event where it's only happening at one of the stations, or if it's a larger scale event, which larger scale I mean across town where it's getting picked up at all of the stations, is definitely going to be incorporated into all of our future work. But yeah, it's fun that you can see all of those individual effects being in the valley, and I think Viking Ranch is definitely a hot spot.
It's a big challenge in ecology and environmental science, where these cut points are. I know some of the data, like the space data, you really can't force it to see any finer or make any inferences about that. It's manipulation of a whole bunch of factors over a larger area.
Exactly. That's why we're so happy to be equipped with these stations right here in town. So, yes. Yes.
I'm suspecting maybe the other 50% that's not to do with the wind and airborne travel sometimes, not just stuff.
Right. I would love that report. That's a great thought. Yeah, I would love that report. Thank you for bringing that up. Yes.
And it's not just wind velocity, it's, you also monitor, I take it, wind direction.
Yes. Yes, we do. Yep, we have wind direction and wind speed.
Because it sort of seems to swirl sometimes, and we can see it come out of Coyote Canyon and head south, but then something happens and we get the other wind direction and all of a sudden we get blasted.
Right. I have a feeling if we're having the northerly winds, we're getting a lot of the dust that's coming from like the Ocotillo Wells area, and then from Coyote Canyon if it's coming from the north. So yeah, that's definitely something that will be incorporated and that the regional weather model picks up on and simulates. So yeah.
The models that you're putting together, will it help us interpret changes as the Salton Sea changes?
Yeah, I mean the MERA data has surface dust concentration, and it also has some of the other pollutants. It measures basically the total amount of scattering throughout the atmosphere, and then it can also categorize the pollutants because of how it makes its measurements. So it definitely will be able to show trends in our, we go back to the, just kind of the scale of the data. I think the Salton Sea kind of lays over 3 of these grid boxes here. So we'll be able to see, how it's changing throughout that region for sure.
I think he was also asking about the model.
Yeah. Oh, I'm sorry, about the actual model. Right. Yeah, so that's something that SIGAR is starting to look into, is creating the model for not only Borrego Springs, but also the Salton Sea region. And that will be able to detect changes in dust. And as for the other particles, I'm not quite sure if that'll pick up the other particles. Sigar, you have more input on that?
We can definitely include different aerosol types that you already mentioned. But
Yeah.
But right now, in the model, we're having some problem. Like the models, the regional models that are considered the best model, even those models are not getting the winds right. So we need to do a lot of tuning and finding different kind of physical parameterization so that we get the winds right, right? So only then we can project what will happen in the future. So right now we're just evaluating, is the model working fine? So we see some problems in like the surface wind patterns because there is a lot of topography involved here, and these coarse scale models, they usually neglect the effect of topography. So it's very, these hills and mountains, right? And these trees or vegetation, everything. So these are neglected in larger scale models, but we want to include everything and we want to get the winds right first. So that is what we're doing right now. And after that, we can certainly let the Salton Sea dry, or and then what will happen. So we'll be able to project and accurately model the what will be the exact location of the dust source and how much actually will be lifted out. So we can get all these detailed answers once we get the model right. So right now it's include everything possible and then get the model working.
Thanks. Yes.
So if you get the model right, as you said, it's conceivable in the future that you'll be able to differentiate between different types of influences. In other words, how much valley fever alert today? How much pesticide alert today? How much toxic levels of the eroding Salton Sea today? As opposed to what I would call clean dust, which is something coming off of the dunes by the dump, or maybe even the off-road vehicles, which is still basically dust. But starting to differentiate between levels of things that we should be more concerned heard about, or that might influence, decisions about what they do about the Salton Sea, which the newspaper was full of this week, and things like that. So you were saying MARA or something is a system that breaks down, calibrates what the different events are in these things. So that's something you might be looking into in the future, maybe, is levels of
Yeah.
pollution of different types.
Yes.
Within the dust?
Yes. Yep. I have looked at pollutants that aren't dust, sulfates and other things, and not as in depth as the dust measurements. But that's something that Mara does provide, and also, like Sagar said, he'll be able to simulate the sources of the other pollutants as well. So valley fever is kind of a different beast in itself because it's a fungi, so not necessarily a pollutant, but the different pollutant levels like the sulfates or the nitrates or ozone, stuff like that, that's not healthy to breathe. Yeah, here, like those 6 criteria pollutants that the EPA monitors.
Let me
Yeah.
add that in a model that of the breed that we're running, we can look at the average particulate